As you may have suspected by now, when we do statistics, it's not very often that we can prove something outright. This usually does not happen. What we can do is provide support for a hypothesis that we have. We can find evidence that supports our hypothesis. We can be reasonably confident, or we can have a certain level of confidence in our data, in our statistics. And so statistics is all about being as confident as we possibly can in order to provide support for a hypothesis that we have. But we usually can't prove that hypothesis beyond all doubt. And at this point, we're sort of bringing everything together. We always start out with a hypothesis. We also call this the alternative hypothesis, and so we'll usually denote it with a capital H and then a little a. And this is our statement of expectation. You can think about it that way. So what do we expect to happen, or what do we suspect is happening? What do we believe to be true? So for example, a hypothesis might be that students at Springdale High School, perform differently on the SAT test than students at Greenville High School. Once we have a hypothesis, a statement about what we expect to happen or what we believe is already happening, something that we suspect is true, we always then want to come up with what's called the null hypothesis. And we usually denote that as a capital H and then a 0. The null hypothesis is always just the opposite of whatever the hypothesis is. So in this case, we said that the hypothesis was students at this high school perform differently on the SAT test than students at this high school. So the opposite of that would just be that they do not perform differently. Students at Springdale High School do not perform any differently on the SAT test than students at Greenville High School. So notice how these are opposite of each other, and that'll always be true for the alternative and null hypotheses. We can also put these into notation. So we could say that our alternative hypothesis is just that the mean of test scores on the SAT for Springdale High School students is not equal to the mean of test scores on the SAT for students at Greenville High School, because the alternative hypothesis, we said they perform differently, which means that their means must be different. The null hypothesis, on the other hand, we would say H sub 0, the null hypothesis, would be that they perform the same. They do not perform differently. So we could say the average score on the SAT for students at Springdale High School is equal to the average score for students at Greenville High School. Now we'll get into this more later, but this is called a two-tailed test because we haven't indicated the direction of performance. We haven't said that students at Springdale perform better or worse than students at Greenville. We just said they perform differently, meaning that the means aren't going to be equal to one another. They're just going to be different. Something like that would be called a two-tailed test because there's no direction indicated in terms of one being more than the other or vice versa. But if we said instead that students perform better or worse, so maybe we say here, students at Springdale High School perform, let's say, better on the SAT than students at Greenville High School, then that would be our alternative hypothesis, and our null hypothesis would have to be changed to reflect that. So we would say that students at Springdale High School do not perform better. We wouldn't necessarily say perform worse, because they might perform worse or they might perform equally. The null hypothesis is just strictly refuting whatever the alternative hypothesis is. So here, if they perform better, then for the null hypothesis, it's just they do not perform better. They do not do whatever we said they would do up here. Then we could say that if students at Springdale perform better, then that means our alternative hypothesis would need to be the mean of the Springdale scores is better, greater than the mean of the Greenville scores. In that case, then, for the null hypothesis, do not perform better, we would just leave this as an equal sign. The interesting thing about hypothesis testing is that once we write our hypothesis and our null hypothesis, and we have the notation for those two, what we're actually going to do is test the null hypothesis. So even though the alternative hypothesis is really the one that we're interested in, we always end up testing the null hypothesis. So this is actually going to be what we're going to test. And there are always only two possible outcomes when we test the null hypothesis. Either we reject the null hypothesis, or we do not reject the null hypothesis. We'll talk about in a second how we go about doing that. But if we reject the null hypothesis, that's going to lend support, again, not prove, but just support our original hypothesis. Because think about this example. We hypothesize that students at Springdale do better than students at Greenville. Therefore, the null hypothesis was students at Springdale don't perform any better than students at Greenville. Well, if we are able to do some statistics and gather some data that allow us to reject the null hypothesis, we're saying this is not true. We were able to show that this is not true, which therefore, if we're showing that it's not true that students don't do any better, then what we could infer is that it might be true that students do perform better when they come from Springdale instead of Greenville. So rejecting the null hypothesis is going to lend support to or provide evidence for the alternative hypothesis, the original hypothesis that we wrote. So rejecting the null hypothesis is how you lend support to the idea that you're investigating. If we aren't able to reject the null hypothesis, then that just means that the data we found or the test we ran, the conclusion we came to, was that we couldn't find any evidence to support the hypothesis. That doesn't necessarily mean that the hypothesis is true or that it's not true. We just didn't find any evidence to support it because we were not able to reject the null hypothesis. So now the question becomes, how do you go about rejecting the null hypothesis, or when would you not reject the null hypothesis? Well, what you want to do before you start your test is you want to pick a probability level. So let's say that we pick a level of 10%. When we say 10%, what we really mean is that we're setting a kind of threshold where we say we will only reject the null hypothesis if, when we collect data on SAT scores for students at Springdale High School, we're going to take a sample of the students at Springdale, we're going to look at their SAT scores, and then we're going to find a mean for those SAT scores. So we're going to find mu sub s, the mean of SAT scores for our sample of Springdale High School students. What we're saying with that 10% is that we're setting a threshold such that that mean score on the SAT is unlikely enough, it's high enough, that the chances of getting that score from a random sample of Springdale students is going to be less than 10%. In other words, we would expect to get that value only 1 in 10 times, or only in 1 out of every 10 samples. That's that 10% number. So we're setting kind of a high bar for ourselves and saying that if we get this result that's really uncommon, it only happens 10% of the time, then what that tells us is that we got a really exceptional result. The SAT scores for the students at Springdale is so significantly higher than the scores for Greenville High School students that we would only expect that to happen 1 out of every 10 times. And if that feels good enough to us, that it feels like it provides strong enough evidence, then that's the bar that we're going to set for ourselves as the level at which we reject the null hypothesis. So we'll say then that if we get a mean for the Springdale students that meets that 10% threshold, then we will reject the null hypothesis and conclude that we've been able to provide some support for the alternative hypothesis that Springdale students actually do perform better than Greenville students. Now, what that looks like when we're actually doing the math is that we look at the 10% probability threshold as a z-score. Now, since we're looking to see that Springdale scores are higher than Greenville scores, if we imagine this as a normal distribution and we have this 10% threshold, then what we want to do is look at the z-score here that is associated with this top 10%. So we want this here to be 10% of the area under the curve, and then we're looking for this z-score right here that's the boundary for this 10% level. Keep in mind that if this is 10%, then all the area to the left of this line here is 90%. So we could look in a z-table, look in the body of the table for 90% or 0.9000, and if we look for that value, we find a z-score of approximately 1.29. So a z-score of 1.29. So that tells us that to be above 90% or in the top 10%, we need a z-score of 1.29. We call this value here for z the critical value, and it is the dividing line between the region of rejection where we reject the null hypothesis, so region of rejection. And again, this is a good thing because if we find a score that's in this top 10% here of probability, we're within the region of rejection, we can reject the null hypothesis and therefore provide support for the alternative hypothesis. So it's the dividing line between the region of rejection and the rest of the area here, which is the region of acceptance. And this is the region where if we find a data point within this region, then we accept the null hypothesis and we do not get evidence that supports the alternative hypothesis. We'll talk about this more when we talk about one- and two-tailed tests, but keep in mind that this was a one-tailed test where this 10% threshold of probability all gets allocated to one tail of the distribution, creating just one tail here for the region of rejection, and that's because in our hypothesis we said Springdale students perform better than Greenville students, as opposed to just saying Springville students perform differently, in which case we would have done a two-tailed test, but we'll talk about that more when we talk about one- and two-tailed tests.